It's time to start subnetting. The next video, so now we're gonna talk about subnetting, finally. So we saw in the previous video decimal to binary conversion, binary to hexadecimal conversion, how the classes works, how the subnet works. We tested that in a real router, and we understand as well how public and private IP addresses work and what's the IPv4, and now it's time to get the subnetting done. So the focus in these next 3 videos is solving the first, second, and the third task, which is in here. So our first task, you can imagine, there is a HQ in here, there is a headquarter office, and this headquarter office it's connected to these 3 branch offices. And each branch office uses one network, 192.168.10.0 for Liverpool, 192.168.20.0 for Manchester, and the London office gets the 192.168.30.0. Because these offices are really small offices, these offices never ever gonna pass 254 devices, network devices in there, between hosts and IP phones and routers and printers. So that's why we decided in here, and to use a Class C IP address as a 10 for Liverpool, 20 for Manchester, and 30 for London office. So we're gonna start on Liverpool, and the requirement for Liverpool office is split the network in 2 parts, 2 networks with 100 hosts. So first of all, we're gonna split the network because maybe we got 2 departments. Let's say the departments we have in here, it's the sales department, and we do have the HR department as well. And each department has 100 devices and 100 devices. So they need, let's say they have less than 100, or they need to support at least 100 hosts per network. What I can do is, let me just fix one part in here. This is the 10 network, so that's the number 1 in here. We got the 192.168.10. And the 4th octet, it's represented by binary numbers, and I did the values of each binary number as well, so make our life easy in here. And the reason I represent only the 4th octet as a binary numbers, it's because we can never ever, for this example, change the first 3 octets. Because if you're looking from the prospect of the HQ, when you're doing troubleshooting, for example, and I got a ticket pointing to 192.168.10.55, for example, and I got one ticket related to the IP address. I know this IP address coming from Liverpool office because it's coming from the network 192.168.10. So that makes our life easy. So that's why I can never ever change this one in our examples. So as I say, these are small networks. It's not gonna grow. This is not the best way you can do as a real engineer. As a real engineer, you're gonna minimum starts on Class B address, because you will never know our next day. Maybe today we got 40 hosts per network in Manchester, and a year later I got 4,000 hosts per network, and we never know that. Yeah, we never know the future. So be prepared to get a really scalable network, and think about scalability. Okay, so for this example in here, I'm gonna fix the 192.168.10, which is the network portion, and this part in here is the host portion. So that's the host portion. Okay, let's start. I'm looking for two networks. If I don't change the subnet mask, which is, by the way, over here is a /24, /24, and a /24. If I don't change the subnet mask, what kind of IP address do I get in here? I can get IP addresses from 192.168.10.0 going through .1, .2, .3, .4, so on and so forth, up to 10.254, 10.255, which is the maximum that I get. I can have numbers from 0 up to 255 on the last octet. So the IP addresses I can get in here is from 10.192.168.10.0 and 192.168.10.255. But the IP addresses that I can use are these ones. This we call as a host address. Why they call as a host address? Because we can use these IP addresses in an IP phone, in a host, in a PC, in a printer, and stuff like that. This IP address we cannot use. Why is that? Because it's the network IP address. And the last one we also cannot use because it's the broadcast. Is the broadcast address. So for this network, I can use IP address from 1 up to 254. But the point is, when I configure the network, let's say I got the first PC .1, the second host .2, and the third host .3, and go on up to the host number 200. When I do a configuration like this, and when I'm using the /24 for all of these PCs, when I use the /24, everybody can see everybody in here. Everybody can reach everybody here. And that's not what we're looking for. We got two departments, and we should split the network in two parts. And each network cannot see each other. That's why we're not gonna play with routing now, but basically these two networks cannot see each other. If I got a one PC on the sales department, this PC can never ever ping a PC on the HR department, and vice versa. That's why we're splitting the network in two parts. But the problem is, the first 3 octets we can change. We cannot change that. So what we're gonna do? We're gonna change the 4th octet. We're gonna increase the size of the network, reducing the size of the hosts. And that's the key in here. But the question is, how many bits do I need to borrow from the host portion to create 2 networks? That's the reason I'm gonna write down the corner in here, write down the bit value and the network I can create. If I borrow 1 bit, I will be able to create 2 networks. Let's see if it's that true. Let me take this one out and this one as well. If I borrow 1 bit, I will get 2 networks. So let's check it out. 1 bit, it's from the network section now. It's from the network part. So what can I do with this bit? I can turn off this bit, or I can turn on this bit. When I turn off the bit, I will get the network 192.168.10.0. That's what I get. When I turn on the bit, I will get the network 192.168.10.128 because I did turn on the bit. So from this, network 128, so the bit in here is on, and I get this result, and I get this result. So from this example in here, from where we are now, from the first network, I got the IPs .1, .2, .3, .4, and go on up to .127, and one before of that 126. The next network, which is the network 128, I got IP addresses as a 129, 130, 131, 132, and this one goes up to 255 and 254. Okay. Because I split the main network in two parts, I'm starting losing some IP address. For example, the first IP address in here, the 0, I cannot use because it's the network. And the last one is the broadcast, so I cannot use as well, broadcast. The first one is the network, and the last one is the broadcast. Broadcast. Okay. So how can I fix that? Sorry. How can I play with that? From the 192.168.10.1 up to 192.168.10.126, these are host addresses. Host addresses from the network 0. From 129 up to 254, these are host addresses from the network 128. So I did split in two parts. If I get one PC now, one host, with the IP address 192.168.192.168.10. Let's say 1, and another host with the 192.168. Let's say .10.129, using the subnet mask as a 255.255.255.128, they cannot ping each other. But why is the 128? What's the rule for the subnet mask? The subnet mask, it's the bits of the network portion turned on. What's a network in here? The first octet, the second octet, the third octet, and from the fourth octet, the first bit is the network section. So turn on the first bit. When you turn on the first bit, you get your subnet mask, which is a 128. If I change this for 0, they will ping each other. But if I'm leaving as a 128, the hosts, they know they are in different network. That's why they cannot ping each other, because they know that. We're just learning now what they already know. The routers, the switches, the hosts, the printers, they know these stuffs in here from upside down. So they know everything. But we're learning now how to understand that, how we can play with that, how we can improve especially our performance on the network, splitting the departments in the different networks. Okay, so let's go for the last part of the first example. On the last part in here, I'm gonna build a network table, and inside of this network table, gonna use network table like this, and I'm gonna use two networks. That's the one, and that's the two. That's the second network. So I got on the network. I'm gonna make 3 columns in here, and the first one is the network table. So network, and I'm looking for the first host of each network. I'm looking for the last host of each network, and I'm looking for the broadcast address of each network as well. So the network we're playing with is the 192.168.10.0. That's the first network. And the second one is the 192.168.10.128. The first IP address of the network 0 is the .1. The broadcast address of the network 0 is .127. And the last IP address, the last host of the network 0, so the last host is the 126. Sorry, 126. So let's move to the network 128, where the first IP address is 129, as you can see in here. The broadcast address is 255, and the last host is a 254. If you're using let's say, a Windows DHCP server, you will need these informations in here to build your pool, of IP addresses, the scope of IP addresses. So just remember, you should use the same subnet mask for all of these IP address, which is a 255.255.255.0. Oh, sorry. Almost there. 255.255.255.128. Using this subnet mask, you make sure you're assuming that this IP address, any IP address on this range, talks to any IP address on this range. They are on the separate networks, and just to make sure we got the right answer in here, Liverpool office looking for 2 networks, 100 hosts per network. Inside of each network, I got a 126 hosts, which is okay, and job is done. From now, let's move to the next video. And on the next video, I'm gonna show you a few tips how to improve this process, how to make this process a bit faster, and at the time we get to the third one, we're gonna solve these kind of questions, or let's say more complex than that, in 30 seconds. But this is the basic, okay? This is the basic. So I'm looking forward for the next video, and I see you there.